Okay, solving linear equations. When you're solving linear equations, you're just trying to get x by itself, so you're using opposite operations to get there. So if you take a look at a question like number 1, you have two options. You can start with doing the distributive property. So as I do distributive property, I'll get -3. -3 times -7 will be positive 21x equals negative 108. I then want to get x by itself, so I'm going to add 3 to both sides. This would give me 21x equals negative 105. As I do 105 divided by 21, this comes out to be, dividing both sides by 21, this comes out to be x equals negative 5. Now if you prefer, and this is obviously a preference thing, here's an alternative way of doing the same problem. Instead of distributing -3 inside that parentheses, I can actually divide both sides by -3 to get rid of that coefficient that's out front. This would cancel out. I'd have 1 minus 7x. 108 divided by 3 comes out to be 36. And now I'm dealing with a lot smaller of numbers to finish this problem. I minus 1 from both sides. Negative 7x equals 35. And when I divide both sides by -7, this gives me x equals negative 5. Completely your choice how you want to do that. I just wanted to show you an alternative option. With question number 2, you actually could do the same thing because both things on this side are divisible by -5, but that's just a preference thing. I think most people probably would be better off doing distributive property. So I'll leave the left-hand side the same. -15 minus 5n equals -5 times 3 is -15. 5 times -5 times -7 is 35n. Okay, so when you get to this point, you want to get all your n's to one side, all your regular numbers to the other side. Okay, so I'm going to move this 5n from the left over to the right-hand side, and I'm going to move this 15 on the right over to the left-hand side. Okay, so I'm going to add these up, and it actually turns out that all of my values on the left-hand side add up to be 0. On the right-hand side, 35 plus 5 adds up to be 40n. Now I know that probably feels a little bit weird, but it's okay. As I divide both sides by 40, 0 divided by 40 is just 0, and n equals 0 is actually my solution. If you're ever feeling unconfident in your solution, just take the value that you get as a solution, plug it back into both sides of your equation, and you'll see that it actually works out. Or you could even do something where you plug into y equals, plug this into y1, plug this into y2, scroll to when x equals 0, and you'll see both sides come out to be equal. All right, question number 3, we have a bit more distributive property, but it's essentially going to be the same thing we just did in the previous problems. I'm going to start by distributing -2 inside this parentheses. So this is -10x, -2 times -1 is +2, bring down the -5x. In this case, I'm distributing -6 in that parentheses, so 2 times -18x, not times, added by, and then plus 18. Watch your signs. I say this all the time in my regular classes. This is the place where people make mistakes, is the little tiny errors that add up and make your problems 10 times harder than they have to be. Combine like terms on the same side. So I have a -10x and a -5x. I can combine those together to make a -15x and bring down the +2. On the right-hand side, I have a 2 and I have an 18. I can add those together to be 20 minus 18x. So again, I want to get all my x's to the same side, all my numbers to the other side, and then solve to get x by itself. So I'll add 15x to both sides. Okay, and I'll minus 20 from both sides. Okay, on the left, that will leave me with -18. On the right, that will leave me with -3x. As I divide both sides by -3, this gives me 6 equals x. And again, if you're ever feeling like you're not sure about your answer, take it and plug it back into each side of the equation. You'll see that it works out to make both sides come out to be equal. Okay, so we are going to begin with adding, subtracting, and multiplying polynomials. The most important thing when you're adding and subtracting is basically to combine like terms. Like terms are terms that have the same variable with the same exponent. You cannot combine things that have the same letter but don't have the same exponent. Those are not considered like terms. So the good thing is that when you're adding polynomials together, this plus in between, that's not anything that's going to get distributed in those parentheses, so you essentially can just think of these as one big polynomial, and then again, combine like terms. So I have 7x squared plus 7n plus 8n to the fourth plus 3n minus 3n to the fourth minus 7n squared. Okay, So now we start to combine like terms. I have a 7n squared and I have a negative 7n squared. I have an 8n to the fourth, make sure the sign that's to the left of it goes with it, and a negative 3n to the fourth. I also have a 7n and a 3n. So notice that I tried to box and like square and circle them or whatever it is so it stands out which things are actually able to be combined. And generally when you write your final answer, you put it in descending order. So I'm going to start with the power of 4 because that's the highest power. 8n to the fourth minus 3n to the fourth is 5n to the fourth. Okay, so my next one, 7n squared minus 7n squared actually comes out to be 0n squared, so I don't even need to write anything down for that. 7n plus 3n is 10n, and that's it. Do not factor it. You do not have to factor unless it specifically says factor. Simplify means to literally make more simple. Combine like terms and leave it with no parentheses. When you are subtracting, where you have to be careful is that technically there's a negative 1 that's being distributed into the second parentheses. So you're going to do something called keep, switch, change. Keep the first polynomial exactly the same. Switch this to be an addition problem, so you can put the plus there if you want. Change the signs of the whole second parentheses, which is really the same thing as distributing that negative 1. So I have negative 6n, negative 5, negative 5n squared. And now I can combine my like terms again, just like I did in question number 1. So I have a 3 and a negative 5. I have a 7n squared, and I have a negative 5n squared, and I have a 3n and a negative 6n. Your choice again if you want to put these symbols to like identify what are like terms, but that's up to you just to make it stand out. So again, we start with the highest exponent. Negative 7n squared minus 5n squared is negative 12n squared. Then I have 3n minus 6n is negative 3n, and 3 minus 5 is negative 2. Okay, so that's all there really is to adding and subtracting. Now we'll start getting into multiplying polynomials. As you can see with question number 3, you would either be using FOIL or box method. So the word FOIL stands for first, outer, inner, last. So if you prefer to do FOIL, and I'll show you that I prefer to do box method, but that's your choice, I would be multiplying my first terms together. X times 7x would be 7x squared. Then I'd multiply my outer terms together. X times negative 6 is negative 6x. My inner terms, negative 4 times 7 is negative 28x. And my last terms, watch your signs, negative 4 times negative 6 is positive 24. I can combine like terms with the negative 6x and negative 28x, so I get 7x squared. 6 plus 28 is negative 34x plus 24. Okay, so I'm going to actually do this multiplication right now using the box method, because you'll notice that when you get to a question like number 4, you won't be able to use FOIL. FOIL is only good for when you have a binomial times a binomial. So what I like to do when I'm doing multiplication of polynomials, I like to think of it like an area problem. So I'm going to make a nice box, and I'm going to think of each of my binomials as like the length and width of that box. So on one side I'm going to put x and negative 4. I'm going to split the box between the x and the negative 4. And then I have 7x and minus 6. And again, I'm going to split the box between the 7x and the minus 6. Now I'm basically going to think of calculating the area of each individual little box and then add all those boxes back together to get my final polynomial. So 7x times x is 7x squared. 7x times negative 4 is negative 28x. Negative 6 times x is negative 6x. Negative 6 times negative 4 is positive 24. You'll notice that as you go along your diagonals, that's where you'll be able to see like terms. So as I add along this diagonal, I have 7x squared. As I add along this diagonal, negative 6x minus 28x, once again, negative 34x. Notice the similarities. And then finally, my last diagonal is positive 24. So again, it's up to you if you want to use box method or FOIL. You're still going to get the same answer. With a question like number 4, you pretty much have to use box method unless you plan to distribute this entire parentheses, 3x minus 7, to each of those terms. So in this case, I make it a little bit more like a rectangle. Okay, so I have 3x and negative 7, and I'm multiplying that by 3x squared plus 3x plus 1. And once again, notice that I'm splitting the box in between the terms of each polynomial. So now I'm going to find the area of each individual little box, and then again, add along my diagonals to add up my like terms. 3 times 3 is 9, x times x squared is x cubed. 3 times 3 is 9, x times x is x squared, 3x times 1 is just 3x, 3 times negative 7 is negative 21, x squared, 3 times negative 7 is negative 21x, and negative 7 times 1 is negative 7. As I add along my diagonals, that's how I'm going to see where I have like terms. So I only have one diagonal along here, so 9x cubed. As I add along the next diagonal, negative 21 plus 9 comes out to be negative 12, x squared. As I add along the next diagonal, negative 21 plus 3 is negative 18x. And then finally the last one, negative 7, and that's my final answer for the product of that monomial and that trinomial. Okay, so we are now getting into dividing polynomials. And there's two main methods that you really want to be able to know when it comes to dividing polynomials. You have the reverse box method and synthetic division. There is something else called long division. I don't really recommend it because I feel like people make a lot of mistakes in it. And reverse box basically will replace long division. Reverse box can be used in every situation. Synthetic division can be used as long as you're dividing by something that says like x plus 2 or x minus 4. Synthetic division would not be good for one where you have to divide by a binomial that begins with a coefficient other than 1. So a question like this, you'll have to do a reverse box. Okay, so I'm going to start with reverse box method. So similar to what we were talking about when we were multiplying by box method. So if you think about a box, right? Let's say you knew that the area was 50 and you knew one side was 5, you'd be able to figure out that the other side was 10. That's basically what we're doing here. This is the area, this is the length. We're going to work backwards to find out the width. So when I do reverse box, I generally like to set it up like this. Okay, I'm going to put my divisor, the x plus 2 on top, and I'm going to split between those two terms, okay, because that's like the length or width, and I'm trying to find out the other length or width. Then the fact that I have an x cubed as my highest power, that's what tells me I need to have 3 rows across, okay? So now these terms here, these are not going to go along the side. These are the sums along each of these diagonals. Okay, so this diagonal has to add up to x cubed, this diagonal has to add up to negative 4x squared, this diagonal has to add up to be 2x, and this diagonal has to add up to be negative 3. Okay, so I'm going to start by putting x cubed in the top left-hand corner box. That's always where you're going to start. If I know the area is x cubed and one side is x, then the other side has to be x squared. So I'll do this. Okay. X squared multiplied by 2 comes out to be 2x squared. Okay, so this is where these sums along the diagonals come into play. As I add up 2x squared plus something, it has to end up being a negative 4x squared. So basically, 2 take away something is negative 4. It would be negative 6x squared. So that way 2 and negative 6 add up to negative 4. I know it's a little tricky at first, it just takes a little bit of practice. So I have this area now that's negative 6x squared. One side is x, so the other side has to be negative 6x. I go back to multiplying. Negative 6x times 2 is negative 12x. And now I go back to those diagonals. Negative 12x plus something equals 2x. Negative 12x plus 14x equals 2x. Okay, so it's like 14 minus 12. So I now have an area of 14x, one side is x, the other side would have to be 14. I multiply, 14 times 2 comes out to be 28. Now the problem is that my last box has to be matching the value that I have here, so negative 3. So the thing is I have to figure out 28 plus some box should add up to be negative 3. If I do 31 minus 28, yep, that comes out to be negative 31. Okay, so negative 31 plus 28 would add up to be negative 3, and now that shows me what my remainder is. So what's my solution then? I needed to find the side of the box, okay? So I had the area, I had the length, I wanted the width. So my solution is x squared minus 6x plus 14 plus, in this case is a remainder, negative 31 over x plus 2, or you could have just put it as minus 31 over x plus 2. Okay, so like I said, it takes a little bit of practice, but you'll get it. So we go on to the next example, and because I'm dividing by 2x plus 3, this is one of those problems where I have to definitely use reverse box. I wouldn't be able to use synthetic division, which I'll get to in the next part. So similar to what I just did before, I'm going to make this nice long rectangle, Okay, I'm going to put the divisor, 2x plus 3 on the top. Okay, and then I'm going to see the fact that I have x cubed as my highest power. I'm going to make sure that I have 3 rows across. So remember, these terms here don't go along the edge of the box. They are the sums along each of these diagonals. So this would mean that this diagonal has to add out to be 2x cubed, this one adds up to 7x squared, this one adds up to 2x, and this one adds up to 9. So start with the top left-hand corner. 2x cubed gets filled inside that first box. So you think about, okay, if I know that I have one side is 2x and then the area is 2x cubed, the other side has to be just plain x squared, so that those multiply together to make 2x cubed. Now I multiply. X squared times 3 is 3x squared. Now I have to figure out as I add along this diagonal, 3x squared plus something makes 7x squared. That would be 4x squared. So now I ask myself again, if I had an area of 4x squared and one side is 2x, what is the other side going to be? Okay, that would be 2x, so that 2 times 2 makes 4, and x times x makes x squared. 2x times 3 makes 6x. And again, I have to ask myself, as I add along this diagonal, how do I get down to having just 2x as I add along this diagonal? 6x, take away 4x, would give you 2x. 2x times what makes negative 4x? That would be negative 2. Negative 2 times 3 makes negative 6. And then you have to add on a remainder here. So you have to ask yourself, what take away 6 would be 9? The answer would be 15. So my solution is x squared plus 2x minus 2 plus 15 over 2x plus 3. Okay. I would say most of the cases when you're doing division, you're probably going to end up dividing by just an x plus 2 or an x minus 4. And in these cases, you'll be able to use something called synthetic division to get the same exact kind of solution as you did before, but obviously in maybe an easier way. A lot of people have trouble with the signs and stuff in the reverse box method. So I'm actually going to redo the first question so you can see it comes out to be the same answer, but I'm now going to do it with synthetic division. The fact that I'm dividing by just x plus 2. That's why I'm allowed to use synthetic. So the first thing you have to do is take the opposite sign of what you had inside this parentheses, and that goes on the outside, okay? Because it has to do with roots and factors, but just know that you have to take the opposite sign. You're going to take the coefficients of the polynomial you're dividing into. Watch out for placeholders. If this jumped from x cubed right down to x, you'd have to have zeros in as placeholders. So my coefficients are 1, negative 4, 2, negative 3. Okay, so this is the way synthetic division works. You're always going to start by bringing down the first term. Multiply this 1 times what's on the outside. 1 times negative 2 is negative 2. Add along this column here. Negative 4 plus negative 2 is negative 6. Negative 6 times negative 2 is positive 12. 2 plus 12 is 14. 14 times negative 2 is negative 28. Negative 28 minus 3 is negative 31. Okay, the last number you got, that's your remainder. Each of these values right here become coefficients of your solution. Your solution is always going to start with being 1 power less than the power you started with. Because think about it, you're technically doing x cubed divided by x, so that's why you should be starting with a 1x squared minus 6x plus 14. And again, that last number, that's your remainder. And if you notice, as I said before, I'm redoing question number 1. It's the exact same solution, just with a different method. So you decide what you think is easier. I would say if you have the option to do synthetic, I would always do synthetic. Okay, one more example. So first things first, because I'm dividing by just x minus 4 or x plus 2, that's why I know I can use synthetic. I take the opposite sign of what was in that parentheses, and that goes in the little box on the outside. Now I take the coefficients of the polynomial I'm dividing into. Remember to watch out for placeholders. This is really like 4x to the 4th plus 0x cubed plus 0x squared plus 5x minus 4. I need to have those zeros in as placeholders. So 4, 0, 0, 5, negative 4. Okay, so I continue with that process I just did in the last problem. 4 comes down. Multiply that by the outside. 4 times 4 is 16. Add up down your column. That adds up to be 16. 16 times 4, 64. Add down your column, you get 64. 64 times 4 is 256. 256 plus 5 is 261. Sorry for such huge numbers in this one. 261 times 4 is 1044. Okay, negative 4 plus 1044 comes out to be 1040, and that is my remainder. So my final answer would be 4, okay, being that this is started with x to the 4th, my answer starts with x cubed. 4x cubed plus 16x squared plus 64x plus 261 plus 1040 over x minus 4. Okay, normally you're not going to have ones that have that big of numbers, but I just wanted to point out one that had like the placeholder so you don't forget about that kind.